Thank you for joining us today for our Progress Semaphore webinar, From Unstructured Data to Rich Insights from Semantic Technologies. Joining me today will be Steve Ingram's engineering manager with a whole host of experience deploying Semaphore in enterprise environments. Today we're going to be covering the current business context and data challenges, overcoming those data challenges with Semantic Technologies. What's the essence of Semantic Technologies, and we'll introduce you to the Progress Semaphore platform. We'll also give you a couple of demonstrations of Semaphore and reasons to choose Semaphore for your organization. Following that will be a Q&A with myself and Steve. We'll try and get through to as many questions as we can. If you want to raise a question, just click on the questions tab hand and then type your questions in. Like I say, we'll try and get to as many questions as possible. If we run out of time, then I'll make sure that someone is following up with you after the event. This will all be available on demand straight afterwards as well. So if you want to share that with your colleagues, feel free to do so. But without further ado, let me hand over to my colleague Steve Ingram, who will present this webinar today. Steve, it's over to you.
Thanks, Phil. So my name is Steve Ingram. I lead Semaphore sales engineering for Progress, and I come from a background of more years than I care to mention in search, text analytics, and digital transformation. As Phil said, the focus of this session will be explaining semantics and semantic technologies, but specifically in the context of the business challenges that they address. And we'll also be including a demonstration of Progress Semaphore. But let's start with why you're here. A colleague of mine wants to summarize business IT investment as make money, save money, keep the CEO out of jail. But more specifically, businesses facing four main challenges. There's obviously the pressure to reduce costs, but at the same time, make sure you're meeting regulatory compliance and mitigating the security risks, while now looking towards the future, trying to embrace the benefits of generative AI and artificial intelligence. The real issue, however, is that the tools the organizations are using are not easily suited to the bulk of the data in that organization. So 80% of the data in an organization is unstructured, but most of the decisions are based on the subset of data, the structured data. And it's like looking right when you want to cross the road. That's okay in the UK, Ireland, Australia, New Zealand, Japan, and a few other countries, but it's not a good idea in the rest of the world. And adopting that approach as a standard is a risky business. Similarly, basing all your decisions on structured data is also a bad idea. And you don't have to take our word for it. Last year, IDC put some numbers to the problem. And all these metrics point to the fact that businesses are missing out by failing to leverage what should be a key asset. For example, few CFOs would put up with a system that is less than 80% efficient, with the rest being lost to rework. Similarly, less than half of the unstructured data has any form of analysis applied to it. And that data, as all CFOs know, costs money. And if the data is being analyzed, most of it is being done manually. Now, Gartner also have a pretty bleak view. So before 2023, only about 20% of organizations had the technology in place to make use of unstructured data. I actually think that's quite a high percentage. In my experience, it's lower than that, but that's what Gartner say. Now, but however, that was then, this is now, and now everybody's now looking to try and incorporate unstructured data into their analytics and AI journeys. But what the industry is trying to do is sell you another silo. So if we go back to the 2000s, we were told you need to shovel everything into a data warehouse. 2010, forget that. No, you need to take everything out of your data warehouse and shoehorn it into a Hadoop cluster. 2020, forget that. You need to dump it into a data lake. No, you need to put it in a data mesh. No, you need to put it in a data fabric. And these days, you're being told the answer is a vector database. But accessing the data is only part of the problem, and it's not even the part that delivers the value. If you base your analytics, decisions, and content on platforms that do not have access to that data, you will have second-rate results at best. To realize the value of unstructured data, organizations need to understand that data in whatever format, wherever it exists. But this is not an easy task. So just take one example. If we look at the bottom row on the left-hand table, now I call it, because I'm British, I call it petrol. Americans would call it gasoline, or worse, gas, which means something completely different to me. If I worked for an oil company or as an industry analyst, I might call it petroleum. Or if I was a chemist, I might use the formula. Whereas if I work in the logistics industry, I'm more likely to refer to it using the HAZChem code 3YE1270. But these are all different terms for the same thing. Now, obviously, within a single department, possibly even a single business unit, or maybe a single company, less likely in a single company, but there may be consistency, but life is not like that anymore. Back in 2008, Gartner identified that organizations are evolving towards what they refer to as the hyper-connected enterprise, where organizations move from a centralized structure towards a more complex and distributed configuration where suppliers, partners, and even external agencies such as customers can contribute to an organization's effectiveness. Now, as ecosystems widen, your complexity increases and your understanding decreases. Now, Gartner was sort of 18 years ahead of its curve. IDC have some catching up to do, but they are doing that. So they now recognize that by 2026, 40% of enterprises will double their investment in hyper-connected digital spaces. And if they don't, they will be overtaken by companies that do. But yet another platform can't be the answer if you're looking to exploit a hyper-connected digital space. By definition, you have to be able to work with different systems and different audiences and different input. Even IBM doesn't expect that every business in the world have an IBM mainframe these days. And we're definitely not going back to that state. But so what businesses need to do is capitalize on what they have now, understand what they have, and more importantly, understand what that means. This needs to be done in a way that can be applied right across the organization in a reusable manner, which embraces the 80% of data that is unstructured and stays current. So it's flexible and can be easily adapted as situations change. And that's where semantic technologies come in. Now, what do we mean by semantic technologies? Semantic technologies is all about meaning. It's all about making that meaning explicit and making it usable by everyone. So it can be exploited by humans and automated tools equally. It's also about using language. So we're not just looking at patterns of text, not looking for just strings. We're looking for things. We're looking at meaning, not keywords, where that meaning is expressed as metadata on an item, whether or not that's a news article, a database record, a web page, a document, a contract. These are all sort of text artifacts, and they will all have metadata on them. First, let's have a look at a little bit of terminology, which I'll try and simplify things, but sadly, we can't avoid some of these terms. A concept is a word or phrase used so an idea can be conceived in your mind or somebody else's mind. Now, all organizations communicate using concepts. Profit, full-time equivalent, FATCA, for FATCA compliance, top secret. These are all concepts which have a kind of agreed level understanding between all organizations. But as we saw in the petroleum example, concepts can quite frequently have multiple labels. So petroleum, petrol, gasoline, these are all different labels, but the underlying concept is, well, the explosive thing that you put in your car. And a relationship refers to the way that two or more people or things expressed as concepts are connected. Now, all organizations communicate using concepts. All organizations run using the relationships between concepts. And it's these concepts and these relationships that define how a business operates. To exploit them, they need to be captured, and also to exploit them, we need to understand what each concept means for an organization. So what is the agreed definition? And we capture that in a knowledge model to make it reusable. Now, all organizations have a knowledge model or multiple knowledge models, but they almost certainly don't call it that. So let's look at knowledge models. Now, in an academic presentation, this is where I'd be using words like taxonomy, ontology, A-box, and T-box. But don't worry, I prefer to keep things simple and to the point. And if I use those terms, it will be only very slightly. We're talking about knowledge models, ways of encapsulating knowledge. And there are a few types of these. The simplest is it's a list. It's what's referred to as a controlled vocabulary. This is a restricted set of permissible values for some property of an item. So this example is a list of countries that we operate in. It's not a complete list, but it's a list. Obviously, if you're purchasing a car, there are a finite list of colors you can buy that car in. And again, that's the controlled vocabulary for the color for that car. And controlled vocabularies are quite powerful. You know, a simple list of products is all a bank needs to determine if it's mis-selling. And in the UK, at least, mis-selling products for a bank can cost sort of 9 figures in damages. It's simple, but it's powerful. Now, controlled vocabularies, you can represent them quite happily in a spreadsheet, and in many cases, that is exactly what an organization is doing. Let's take things a step further. Now, a taxonomy, it's a controlled vocabulary. It's a set of permitted values, but we've enforced a hierarchical relationship over these terms. It's a rigid hierarchy. We can only have a hierarchical relationship. And the name obviously comes from taxonomy with a capital T, which assigns all living things to domain, kingdom, phylum, class, order, family, genus, and species. In our case, we're being a little bit simpler, and we're just grouping these countries geographically. But this could also represent products and components if we're looking at a help desk application. And this is also something that can be represented in a spreadsheet. Now it starts to get a little bit more complicated. A polyhierarchical taxonomy is a more complex model where an individual item can have multiple parents. So, for example, Russia can be considered part of Asia as well as part of Europe. Now, immediately, this causes problems for any tabular representation, because if you wanted to track any properties for Russia, like capital city or currency, we'd need to duplicate those entries. And as soon as you start duplicating entries, you start to get problems. So we need to start thinking about other representations. Now, before we get to sort of the final state, let's look at a thesaurus, because there are concepts in a thesaurus that can be easily usable in a knowledge model. So like a taxonomy, a thesaurus has hierarchical relationships. So you have the concept of a broader term, North America, narrower terms, Canada, and the United States of America. But it also has other types of relationships. So we have equivalence relationships. So USA, Uncle Sam are other ways of referring to the United States of America. Great Britain, England, other ways of referring what should be properly referred to as the United Kingdom. And you also have the ability to create relationships going across this thesaurus. So you can have related concepts, you can have synonyms, you can have antonyms. So this sort of richness becomes very difficult to represent in a spreadsheet, and you typically use something like XML to represent this. However, the relationships that you include in a thesaurus are fixed. The thesaurus is only describe the meaning of words. So what you need is something that has the richness of a thesaurus, because the thesaurus describes the language in the way that our knowledge model describes a business or a challenge for a problem. But you need to be able to describe more than words. So a knowledge model contains both hierarchical elements, so it looks like a taxonomy. It contains equivalence elements, so it looks like a thesaurus. But the relationships are not limited to the meaning of words. You could, for example, include, given that we have a countries example, let's consider we need to identify countries that share a border, maybe countries that are former colony of. And a knowledge model also allows you to specify sort of quasi-hierarchical relationships. So if we have international bodies, like such as NATO or the European Union, we can create relationships to those organizations without having to mess around with our hierarchy. So we don't need to decide if France is part of Europe or should France be under the European Union. Our knowledge model will have both of those relationships managed. And another important note is that knowledge models will never be static. They must respond to changing circumstances. They must respond to changing circumstances easily without needing a huge amount of effort to retrain them. So, United Kingdom, sadly, no longer part of the European Union. So I just want to be able to update my model. I don't want to have to look for huge amounts of content that describes United Kingdom being outside of the European Union to replace the fact that it is inside the European Union. What I want to do is just be able to update my model and say from 31st of whenever it was, the UK is no longer part of the European Union. They have to be flexible. Lastly, a knowledge model also includes the concept of classes. So we have continents, North America, Europe, we have countries, we have international bodies. Now, sometimes a knowledge model like this is referred to as an ontology. Although strictly speaking, the ontology is literally just the relationships and the classes. But as you can see, if that was just our ontology, just the four relationships and the three classes, that isn't going to be enough to describe the business operating landscape. You need the instance data, you need the concepts of Canada, the concepts of Russia, the concepts of United Kingdom. You need the specific items. And this is why a knowledge model contains an ontology, but it is not the end of the story. And if anybody who says all you need for semantics is an ontology, that might be true in academia, but it's absolutely not the case in business. And definitely you cannot manage an ontology. You cannot manage a rich knowledge model in a spreadsheet. There's too many relationships, there's too many properties that need to be carried across. Now, I want to just talk roughly about how using a knowledge model can help analyzing unstructured content before we actually go in and look at that for real. So let's just consider a piece of text. Now, we can apply our knowledge model, just the one you saw previously, to this text and identify the countries that are mentioned in that document. And we can use, for example, synonyms or alternative labels to say that we've found Germany, even though the text is talking about West Germany. And we can also score our results based on the amount of evidence that we've seen. So Canada's mentioned twice, therefore it has a slightly higher score. But we can also use the relationships to uncover hidden information. So because we have 4 members of NATO, so in our model it says that Canada, United States of America, United Kingdom, and Germany are members of NATO, we can conclude that this text is likely to be about NATO. So you can see the confidence score might be a little bit lower. But even though NATO isn't actually mentioned anywhere in that text, we can say that the meaning of this text involves, as well as the countries, it involves the North Atlantic Treaty Organization. And that's where the richer your model is, the more benefit you can attain from it. So you have a model, you can then apply that model to your text, to your unstructured content. What can you do with that? Obviously, you can monetize that content. So if you know what your content describes, you know what your audience wants, you can make sure that your content gets to the audience that you want. But conversely, you can also make sure that certain audiences don't get your content. So you can secure your sensitive content, you can enforce export control over that. You know what the underlying concepts are described in your text, in your unstructured content. Therefore, you can harmonize your data. So the team that refers to petroleum can work with the team that refers to gasoline. They can access the same data and remove the need for rework. You can drive workflow. You can easily find the information you're after. You can assess, augment collaboration. And importantly, you can also improve your decisions, because by understanding what your content's all about, you can then use that to make better, you feed it into BI products, and you can use it to make better decisions. Now, one thing I do want to point out here, these knowledge models do not need to be created from scratch. They already exist in your organization. They won't be called knowledge models. If you happen to work in a pharmaceutical background, you will have taxonomies, you will use them, but other industries have these definitions. They may not call them knowledge models. But what you don't need or indeed want to do is waste time and resources in an AI or machine learning project to teach you what you already know. If you have this information, the best way is to find an efficient way of getting the information out of your users' heads into a form where it can deliver value. And I'd like to now show you how our product, Progress Semaphore, can actually drive that process. So firstly, what I'd like to do is show you how with Semaphore we can use knowledge models to enrich unstructured content. And I'm going to do that with a browser. And so this is Progress Semaphore. This is the version 5.8. It's just hot off the press. And what you're looking at right now is what we call the document analyzer, which is a useful tool to see how what's inside document, what's inside text, and to see how the system responds. So I'm going to drop in a Word document. In fact, let me just drop it in. So it's a Word document, and I'm going to classify it against my my server. So my copy of Semaphore. So on the left-hand side, we have the text that we've read. So one thing Semaphore can do is read the text out of binary formats. So it's a Word document. Now we have the text. And then on the right-hand side, we have the concepts that we found in this text. So these all match a knowledge model that we have of space missions. And we can see we have various different categories of information coming back. We have astronauts, we have launch vehicles, we have missions, we have organizations, and we have programs, and we have some general topics as well. And these are the values that come back, and then every value has a confidence score, and we're not showing you anything that we don't have enough confidence, anything that comes below a threshold value of 0.48. Now, interesting, if we actually look at this document, we can see that this document is about, according to our model, it's about the Apollo 11 mission, and it is, we can say that quite confidently with a 90% confidence score that this is about Apollo 11. But if we actually look at the document itself, we can see that the document may have, well, we find the options, not that one, may have plenty of references to Apollo in there, but there's no references to Apollo 11. It's because I took them all out. But this is the Wikipedia article for Apollo 11. And we can see that we decided it. So we've determined that it is about Apollo 11 because of all the evidence that's in our knowledge model that we found in this document. So while Apollo 11 is not mentioned, the launch vehicle for Apollo 11 is mentioned, the call sign for Apollo 11 is mentioned, the destination of Apollo 11 is mentioned, and it has the reference IDs for the Apollo 11 mission. But not only sort of that obvious element, evidence, if we look at the astronauts that are coming back, and we just sort these by score, you can see that the top 3 scoring astronauts are Buzz Aldrin, Neil Armstrong, and Michael Collins. We are the crew of Apollo 11 as identified in our knowledge model. So given that it's talking about these 3 people, when plenty of mentions of it, so very high confidence scores, it's about these 3 guys. Therefore, we can conclude that it's likely to be about Apollo 11. Maybe about other missions, maybe Gemini missions, but 2 of them were mentioned on, but there's enough evidence in there for it to be about Apollo 11. And that's what we mean by semantic classification. We are saying this is what this document is about. This is how it fits onto our knowledge model. So let's actually look at that knowledge model. So we're going to go open up another window. So Semaphore is a server-side tool. It's browser accessible. There's no need for a thick client, and it's designed for collaboration. So I'm going to look in, go into our modeling piece, and then I'm going to run what we call Knowledge Model Manager. So these are all different knowledge models. You can use them individually, you can use them collectively. But let's just look at the space missions model itself. And let's look at the Apollo 11 concept. And we can hover over it, and yes, we can see that that is what we're after. So now I'm looking at Apollo 11, and this is what we mean by concepts and relationships. So this is the concept of Apollo 11. I called it Apollo 11. I have no idea how this would be pronounced in Korean or Chinese, but that's how they refer to it. But we also have alternative labels, so other ways of referring to Apollo 11, which could be just general other ways of referring it to it, or they may have some additional meaning. So because it's a mission, as you can see from the class, it has a call sign, it has a cost per ID, and has SCN ID. Whereas an astronaut probably might have a call sign, but more likely to have a nickname. So you can make sure that your model matches whatever it is you're defining. You don't have to decide up front what your data schema is going to be. It adapts to what you have. And then we have our relationships. So as I said, we have the Apollo 11 concept. We have our crew, Buzz Aldrin, Michael Collins, Neil Armstrong. These are also concepts, so it's fully navigable. As you can see, Neil Armstrong crewed Apollo 11. He also crewed Gemini 8. And you can start to use this. As you can see, when you expose this to tools that can browse it, then you can start to discover, help people to discover new things they didn't necessarily know within their data. But let's go back to Neil Armstrong. Let's go back to Apollo 11. Now, you may look at this and go, this is an awful lot of work, but it isn't. We don't actually, this model is not maintained. We just have a script that builds this from DBpedia and Wikidata. So you can you know, if you have access to these reference data, you can import them, you can bring them in from other data sources. And so you don't need to go to this level of detail, but obviously if you do, the richer your model is, the better results you can get from it. And as I said before, with Semaphore, it's a collaborative platform. So it's all about letting the people who know what they're doing contribute to those, to the knowledge model. And just for completeness, on the right-hand side, you see we have what we call signpost terms. These are some of the tools that we provide in the product to help a subject matter expert maintain the model. And this is actually making suggestions for other concepts that may be related to Apollo 11, and that's using an index of Wikipedia articles. So we have a knowledge model, which can be maintained collaboratively or imported, and then we're using that to enrich content and determine, actually find out what is the meaning within this unstructured data. And these concepts, sorry, this on the left-hand side, on the right-hand side, I apologize. These are all, if we were to store this document in a CMS or in SharePoint, these would all be metadata values that we stored alongside the document, and then can be used for search or discovery or additional analytics. So, as you saw in the demo, with Semaphore, we can use a knowledge model to extract metadata from text, from unstructured data. But what do we actually mean by this? Metadata is information that describes various facets of an information asset. So it's data about data. And metadata is critical for managing unstructured content. What we need to do, and what we do is distill the text in documents, web pages, news articles, free-form comments in a database, and we distill it into actionable metadata. We have studies, for example, that show that well-defined metadata can make content 50% easier to find. And that's immediately applicable where time spent collecting information is important, such as customer support, legal applications, or even sales management. But what do we actually mean? So let's look at sort of how much data is in a sentence. So on the left, we have raw text. It's human readable. It cannot easily be exploited by any automated process or analytics tool. This is an adverse event report. This is something the pharmaceutical companies need to deal with whenever they're putting products out into the market or during trials. And there will be key pieces of information here and there. There'll be patient information, there'll be ethnicity, there'll be age, there'll be the trial they're undertaking, there'll be drugs they're taking. But there's no consistency in the format. But if we have our taxonomies, we have our linguistic processing, we have our understanding of text, we can return actionable metadata. So if we represent that text is JSON or XML, then this can be processed by downstream applications. But what we really need is for this transformation to be done once and have the logic represented in our knowledge model, not implemented in multiple business applications. So we don't have to recode how to read this text for each application that wants to use it. What you need is an enterprise strength semantic middleware that can sit between your applications, can sit over your data and make sure that data from team A is available for other audiences. And this is the problem that Semaphore addresses. So what is Progress Semaphore? It's a semantic AI platform that enhances data with meaning and context using a knowledge model and semantic relationships. It's all about generating metadata and then allowing you to use that metadata for solving business problems. How do we do it? There are three main components. There is the modeling piece, which is all about finding the knowledge models, importing them into Semaphore, allowing your subject matter experts to maintain them in a fully collaborative and fully controlled manner, and doing so in an open standards-based way so it can be made available to other applications. We can then use those knowledge models, we can combine them with an NLP engine to enrich, extract, and harmonize unstructured content or content. And lastly, it's making that enriched content and those knowledge models available for other applications to deliver business value. So what sets Semaphore apart is our fundamental belief that the human still has a role to play. Semaphore is not a black box or an application sitting out somewhere in the cloud that's prone to hallucination. It's based on your data and your knowledge. So every annotation made by Semaphore is deterministic, it's traceable, and auditable. So what we're delivering is, enriched content. We've added a descriptive metadata that allows it to be used right across your organization by multiple teams to deliver the value. And finally, so with Semaphore, you can unleash the value in that 80% of unstructured content that really isn't being utilized properly. Now, I'm going to show you what that kind of looks like. But what I would like to do is point your attention to it's up on the MarkLogic YouTube channel, which is Data Harmonization for Better Business Decisions by my colleagues, Jim Morris and Stephen Reed, which covers the same territory. We'll go into much more detail. That was delivered about a month ago. Can't recommend that enough. So let's now look at exactly what we can do with semantically enriched data. So in this demonstration, I'd like to show you the sort of benefits you get from using semantic approaches to extract more from your unstructured content. I'd like to switch to an application which is built using another Progress product, the MarkLogic database, which is a multimodal database. Now, this is showing you the idea behind this application is if I was an analyst, looking at investment decisions, or if I'm looking to understand more about particular industries, I may have at my disposal SEC Form 10Ks, which are annual reports from US listed companies, and I may have thousands of these. So what I've done is I can read them into MarkLogic. I can annotate them using Semaphore. And what Semaphore is doing is not only looking at, it may have taxonomies or knowledge models around industry, but it also has a knowledge model about understanding a Form 10K. So what I can do is not only make this available, but actually I make my understanding of this data available. So let's say, for example, I wanted to do some research into companies that are domiciled in California. And these are all PDF documents. They are all fully searchable. MarkLogic is a very powerful search engine. So I can look for, I just do a search for California, and I'm going to get back, a stack of results because California gets discussed a lot in these documents. US companies, they're actually quoted. So let me, but actually what I really want to do is I want to see what companies are domiciled in California. Now, because I have a model which understands how Form 10Ks are put together, I can actually query this. I can be more intelligent about my query. So I can actually say, rather than just give me free text results for California, give me any document where the 10K jurisdiction is California. If I do that search, Now I get back to my one document, and then I can start to actually explore that document. I can look at all the information from there. I can see what the further information that I may need to do. But I'm not just limited to retrieving individual documents. If I actually want to, let me just repeat that. Sorry, I'll rephrase that. I'm not limited to individual documents. I can actually treat this database of documents actually as an information source, because I have a semantic model that explains to me or tells me what the information inside these documents is, which means I can actually start to do some queries. So maybe we actually want to see these documents. So we want to see what the jurisdiction is. Maybe we want to actually see the market cap, and we can start to not only treat this information kind of in a tabular manner, but we can also start to chart it. So maybe I actually want to see how the companies break down. I can then execute a query. So literally, we are executing queries over our PDF documents because we know how to read them. And these are all just PDFs. There's no XML in here. They're just PDFs, and we know how to read them. Now, what do I mean by knowing how to read them? So if we go back to, if you remember our space missions example, where we're deciding that we've processed our Word document, and we are deciding this document is about Apollo 11 based on the evidence we're seeing in there. Now we can use exactly the same tool to dive deeper into these documents and surface. So this is metadata, is what we call aboutness, but we can actually surface facts from the documents themselves. So this is the 10K for one of the companies. Actually, it is it's a company called Gentherm. And let me just see if I can find the original. Let me just open this up. There you go. So as you can see, it's a PDF. There is various pieces of information in there, and we have a model for understanding Form 10Ks. So we can mean that we can actually surface this information. So we can, as you saw before, we can identify the jurisdiction. In this case, it's Michigan. We can identify the market cap. We can identify where the reporting date is. We can identify who the signatories are. Now, some of this information you could hazard a guess at. So if you look at a PDF, you can see where the entity might be named. You can absolutely see the reporting date. Easy enough to find. But market cap, it's not in here. If you search for market cap, you won't find it. But what there is in here is somewhere in this text will be a paragraph that is describing the market cap, and there's a certain degree of consistency in how this is put together, not in the actual format, but just how things are expressed. And in here will be a value that is the market cap for the company. And this could be nicely expressed as a delineated currency amount, or it could be $1.4 billion. Or I saw one example which was would have been represented here, 1,433 million. Doesn't matter. These are all different ways of expressing the same amount, and that's something our NLP engine can handle quite nicely. So what you get in the text is just letters, but actually what you really want is actionable metadata. So we're showing you here, this is the market cap. So then we can start to find the top 3 market cap companies in Michigan. We can start to chart the market value by jurisdiction. And if we're looking at, for example, a know your customer, then we can start to link execs to companies based on the Form 10K. And it's all about understanding how the information is expressed and using that to populate our document, our metadata representation of the document, and then indeed making it available for further processing. So why choose Semaphore? So just to finish, Semaphore is all about reusing your existing assets. So the knowledge in your people's heads, the data that they already have, We're not about reinventing the wheel. We're not about passing control over to some AI running somewhere. It's all about what you have and making better use of it. Using Semaphore, you can deploy solutions faster and more accurately than by relying purely on an AI and machine learning. So why choose Progress? Well, our numbers kind of speak to our experience, and these surveys are all done with our customers directly. More than 70% of the Fortune 500 depend on Progress, and well, you can see those numbers there. We score very highly, not only for coverage, but also for emotional footprint. So customers actually like deploying Semaphore, and they like working with us. So to summarize, you have a huge asset in your organization that traditional architectures, traditional business information tools are not serving. More importantly, these are typically scattered across your organization, or may even be outside of your organization using different frames of reference. And what Semantic Technologies will let you do is meet the challenges you're facing now by bringing those assets, leveraging them, and getting better benefit from them. So with that, I think it's time for Q&A. Yes, unfortunately, we've had to lose Phil. So it's I'm going to be doing the Q&A. We've got a number of questions come up. Really cool. In fact, straight off the bat, question: how do you identify actionable insights? Ideally, like to say it's a magic system. We automatically tell you stuff you didn't know you needed to know. But yeah, unfortunately, it's not like that. So it's Donald Rumsfeld, if anybody remembers him, would refer to it as known knowns, known unknowns. You need to be aware of the sort of information you're looking for. So it's use case based. Sorry, someone just said I'm still on mute, but according to my system, I'm not. So we just note a note on chat if you can hear me. Excellent, thank you very much. Yeah, so you need to know, so it depends on the use case. You need to know what it is you're looking for. So typically, if you're looking at contract processing, there's some key items of information you want to retrieve. So we can't, it's not magic. We can't tell you stuff we don't know, but there's a lot of flexibility in how you can express the sorts of things you want to retrieve from content. As I said really early on, if you could just have a simple list of products, you just process your communications with your customers to see if any of those products are mentioned, and if the wrong products are mentioned with the wrong customers. That's the fact you're looking for. Very much use case based. Where are we? So a couple of questions on the same sort of topic. Are there any potential limitations of semantic technologies when applied to different types of content? Different types of data, multimedia, social media, etc. And the question also on the same sort of topic around 2D and 3D data. We're limited to text, so there has to be text in there somewhere. Either it comes from an OCR or it comes from a transcription. But Semaphore is all about processing text. Sadly, images is not something we can do. Another one. Where are we? How does this is quite close to my heart? So how does the process of extracting insights from unstructured data differ from other techniques? So I spent 15 years selling search engines, and there are a couple of things that really used to give me and my companies grief. One of which is I touched on it in the demonstration. So the concept of Germany, as in post-unification Germany, is different from the concept of West Germany, i.e. Germany between 1945 and 1989. And that causes search engines all sorts of trouble. But you can just simply say, I have two concepts, they are different. If you see West Germany, do not fire for Germany. In a medical context, you also have gestational diabetes is different from diabetes. So if you're doing a straight keyword search, your document search for diabetes will hit documents that are actually describing gestational diabetes. You don't want those, but that's very easy to represent. in a model. The other advantage really of using linguistics is variation handling. So the NLP engine knows that run and running and ran are all pretty much the same word. So we don't have to worry about specifying all those as different examples, which you would do if you were just looking at sort of string processing. And my colleague Jim had a long treatise on the word back, which if you're doing search engines, you're stuck with a string of B-A-C-K. But is that a noun? Is it part of a verb phrase? Do we say, the pain is coming back, or do I have a pain in my back? And these are all sorts of things that once you actually have an understanding of what it is being, of how the language, how things are expressed, then it's much easier, and that's where really semantics comes in. These are all examples of the benefit of using things rather than strings. Well, anything else come in? So how long to go from a raw document? Oh, can't read all of that. Hang on. How long to go from raw documents to actionable info? It's pretty quick. So the first step is usually to look at the kind of the aboutness classification. So what we saw in the first case, they're saying, okay, this is a document, actually it's about Apollo 11. That's very straightforward. Once you have a knowledge model, go on to, we can apply various out-of-the-box strategies to the elements in that model, and very quickly you can see, okay, this is what my content is about. So very simply, if you wanted to migrate content between two repositories, you only want to migrate the customers, content about the customers that or products that are actually actively being sold or being dealt with. So you can literally, very quickly understand what your content is about. And the next step would be to actually start to maybe look at some of those fact extractions that I showed in the second demonstration, actually pulling key pieces of information out. So for an example, a manufacturing background, for engineering, the first thing you want to know is what components, what products, what processes are being described in a document. And that's your first step. And then you may want to say, okay, well, I actually want to know when this document was published, this technical procedure was published, who were the reviewers. I want those names surfaced, and I want that as metadata. So it's very much an iterative process. And actually, so it's actually on that topic. Another question around what are the key challenges in deploying these technologies, and it's really around the knowledge elicitation. So as I said, all organizations have a knowledge model. They may not call it a knowledge model, but it's going to be scattered around the organization. So getting hold of that. But something I forgot to mention in the presentation, there are organizations that actually specialize in this. The leader in this is a company called Wand. And in many situations, Wand has a whole library of pre-built taxonomies. Very good, they have great coverage and very easy to build up on there. So if you don't have them, these knowledge models identified, there will be industry models, and there will be models from third parties that will get you started on the process, and you can just import those into Semaphore, and then off you go. It's a very quick process. You don't require to boil the ocean and understand everything within an organization. And I think, so somebody just answered the question, how easy is it to pull knowledge models and/or instance data from Wikidata or other knowledge graphs? So Semaphore supports a standard format. It uses the SCOS-XL standard, so we can also import SCOS. We can also import OWL. Trouble with OWL ontologies is they do tend to be not very consistent in how everything is expressed. So we do like some consistency in there, but we can process them in and use them. If your models are just in spreadsheets, then they can also be imported. We have wizards to help with that. What other questions do we have? Right, question around the user interface. In fact, so there's the GUI for Semaphore is designed as it's designed to be simple and easy to use. So it's designed to be an editorial level tool. There is a graphical component. So I'm sort of pre-seeing the question: can the data be graphical? There's a graphical component you can use to navigate the model. You look at the concept, you look at its nearest neighbours. We don't, as it stands, show the whole tree because people just can't consume that. So people typically navigate to a point and then maybe using some relationship traversal to go from there. But yeah, these things are graphs. Trying to make people force and look at them as tabular views isn't going to work. So Semaphore supports a sort of a graphical, not a graphical approach. But we are obviously trying to, the team that looks after the UX for Knowledge Model Manager is always trying to stay ahead of the curve. And they are looking at how we can make it more usable and more consumable in those sorts of manners. Where are we? Nothing yet. So it's the philosophy around Semaphore Knowledge Model Manager is that the knowledge model is the most important thing. And so everything derives and is driven from the knowledge model. So it is a no-code environment. Once you've set up your knowledge model, your relationships, your classes, configured your classification strategies, then from that point onwards, you make a change to the model, you approve it through the workflow, you then publish it out to the server, and then those new definitions are used for model enrichment or navigation or however you want to do it. It's all driven from the knowledge model. Where are we? Does Semaphore support exporting? So we can support in a variety of formats. So the question was, does Semaphore support exporting all or some of the knowledge model for use by other applications such as Neo4j or Python NetworkX or KGLab modules? So we export in, so Semaphore uses, yes, we're Sparkle based, so it's going to be RDF based. We can export in a variety of RDF formats, TTL, NTRIPL, RDF XML. We can also export in JSON LD and in CSV format. So we don't directly export in property graphs, but the publishing mechanism is extendable. So we publish into MarkLogic as a triples, or we can publish into MarkLogic database, and so you can easily extend it to write to other mechanisms. Either we could do it, or it's an open API, so you could do it yourselves. Any other questions? So let's. Oh, no, that's the CD data question. Can we elaborate on the role of NLP within Semantic Technologies? That's covering off the same area. It's all about the use of language to help make better sense of the text we're working with. Key challenges. Done that one. Examples. Good point. So, what examples of Semantic Technologies helping? We have it's going back a bit, but it was an organisation that looked after senior citizens in the US, and they had to pay out if any of their clients had a injury after an operation, and they were finding that people were falling, and if they were falling, so it was a major call. People having to go back into hospital because they'd slipped or fallen in their own home. And because these guys actually looked after both the accommodation and the medical treatments, they were able to pick up on some of the notes around, not only look at the medical treatment and the condition and the treatment. But if there are any side effects that might lead to drowsiness, they would then able to look for circumstances in the home. You know, was it low light? Was there stairs, steep staircase, badly worn carpet? And so they're able to look at perform queries right across the sort of notes about the environment as well as the medical information, and then identify the people who were at risk of falling, and then they could go in and put brighter lights in, or repair the carpet, or put action in place, or if they weren't able to do that, prescribe medication that didn't lead to drowsiness. And so it's looking at sort of all the elements that typically you wouldn't be able to take into account if you're using your sort of static, your conventional sort of structured data. Other examples also in pharma. So looking at what people are saying about products they're taking, trying to identify any problems that might be developing down the line. And again, it's all based on people expressing, expressing the same problems in using different language. Where are we? How are we doing for time? 5 more minutes. Can semantic technologies address challenges in a multilingual environment? I hope I showed you that in the demonstration. So Semaphore is multilingual. You can model in any language that has 2-letter codes. Of course, accommodate dialects. And then we have the classification engine. The NLP engine uses, again, it's got another 50-odd language modules in there that have different levels of capability. So there's about 30-odd for which the language support is quite advanced. It's not just English, so Russian, Chinese, Arabic, French, German, Spanish, where they support the full German. They support the full length, full capability in terms of how sentences are constructed, compound words, entity identification. So this is a name, this is an address, this is a currency, this is a person, that kind of thing. And that's about 30 languages. Those do need to be licensed separately, but it's you can model. If you're not going to use the modeling for classification, you can model any number of languages within a knowledge model manager. And I think if you, in the demonstration, we have 2 types of label. There's the preferred label where there can only be 1 per language, and then there are alternative labels, and you can have multiple ones of those, different ways of expressing that. And again, it can be done in multiple languages. Within Semaphore, to support that, we have a translation tool. I didn't show you when I showed you in the demonstration. We had the lexical resources showing the signpost terms and other suggestions that may be related concepts, related terms for your concepts. We also have a translation side panel. So if you have labels in English, you want to add Russian or Chinese or Arabic or Japanese labels, you can use the translation tool to do that, and that we use Azure Cognitive Services for that, but you don't need a license for Azure Cognitive Services. We've got one that will cover for everybody, cover everybody's use of that. Another question in. Surface map of any 3 variables or concepts. I've not seen that for many years. I saw that and we've done things along those lines around search engines. So looking at a cross product of 2 facets, but I've not seen it in a kind of knowledge model, knowledge modeling environment. So any others? Where are we? Can you provide insights into the potential applications of semantic technologies for personalization? That's quite a nice one. We had a discussion with that internally a couple of days ago. One of my colleagues is exploring what's the word I'm after? It was one of our customers that sells sporting goods, and they were able to browse and find things that match what they're looking for better using the customer that's using Semaphore. So it's actually marking up the content. So you can go from what you're looking for, which would be expressed in your terminology, but you want to see what and what Semaphore is doing is mapping that onto the terminology that suppliers may use, and the marketers may use for the same product, and able to find that. And he was finding it easier with the Semaphore site than he was with some of their competition. Okay, I think that's probably it for now. So thank you for your time. If there's anything we can help with, please don't hesitate to contact us. So thank you very much, and bye for now.